C at those points, which I'm not super concerned about you plotting them. So if we plot A at negative 6, 8, B at 4, 8, and C at 2, 2, and we connect A to B, would it be easy for us to find the distance from A to B? Yeah, absolutely, right? If we created segment AB, we could use the coordinates to find the distance, or we could simply count the boxes to find the difference, okay? The distance. So hopefully you got that the distance was 10. You could have done that by saying how far is it from negative 6 to 4, which we'll go over in a minute, or you could have literally just counted the boxes between A and B. Now, it's a different story when it says, what about the length of BC? Now, on the coordinate plane, you're allowed to count horizontally, you're allowed to count vertically, but are you allowed to count diagonally? Like, count the boxes. Does that work? If I counted, like, that red segment diagonally, would I be able to tell the distance from B to C? And hopefully you're saying, no, that would not work. You're not allowed to count boxes diagonally, only vertically and horizontally. So today we're kind of talking about the difference between finding the distance from A to B versus finding the distance from B to C. So that's what we're discovering and going over today. Rise over run slope will play a part in it. Not the actual slope, but the actual counting up and over will definitely play a part into what we're doing today. All right. First, let's make sure that we can find the distance between 2 points on a number line, because to be able to find that distance will help us go into finding the distance on a 2D coordinate plane. So let's do 1D before we do 2D. And you're saying it already. All right, yell it out. What is the distance from A to B? Yes, 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 you're right. It is 7 units. Now, there's a few ways that you can go about this. One way I call my common sense way. I use 0 as like my orientation, and I say like, oh, how far is it from negative 5 to 0? That's easy. 5. I didn't even do any math. And then how far is it from 0 to 2? Oh, it's 2. And so 5 plus 2 is 7. So you could use your common sense way, or, yes, you could do what you're typing in the chat. You could do what's called the ruler postulate. So write this in your notes right here. This is called the ruler postulate, the distance between 2 points on a number line. Really? You could just write what's in blue. Just write what's in blue. Just write that. So there's a postulate out there, kind of like our postulate, like any 2 points create a straight line, that kind of thing. There's a postulate that says that the distance between 2 points is the absolute value of the difference. Say it out loud. The absolute value of the difference. The absolute value of the difference. The absolute value of the difference. And we'll talk about what that means. So let me tell you what this postulate is saying in a nutshell. It is saying that you can take the coordinates of 2 points, subtract them, and then make them positive. So difference means subtract. And absolute value means make positive. So what that's saying is you can take any 2 points, subtract them, and make them positive. Do we add them? No, we subtract them. So you could have done negative 5 minus 2. You get negative 7, and then you take the absolute value. You make it positive. What if you had done it the other way around? 2 minus the other coordinate, negative 5. Then you would have gotten 7, and you would have never had to make it positive. So the moral of the story is, if you subtract them and make them positive, you can't mess up. You cannot go wrong. So let's try some. Find the distance between Woody and Elsa. Write your answer in your notes. Find the distance between Lightning McQueen and Flynn Rider. And find the distance between Belle and Jasmine. Don't write them in the chat yet. Just write them in your notes and we'll go over them. No problem. All right, so go. Write your answers to number 1. Go. you always subtract them. Every time, you subtract them every time. Now, it doesn't matter which one you put first, because if you had put the 2 first, 2 minus 37, you just make your answer positive, and you're all good. Next one, Lightning McQueen and Flynn Rider. Subtract them and make it positive. Subtract them and make it positive. Subtract them and make it positive. Very good. Very good, very good. You could think of it as saying, how far is it from 14 to 0? Oh, 14. And then 0 to 8 is 8. So it's just 14 plus 8. Last one, Belle and Jasmine. Go, type your answers. Belle and Jasmine. This one's a little bit harder, but you're all getting it right. Okay. Negative 22 minus, be careful, Jasmine is at negative 6. So don't forget that last negative in there. Negative 22 minus negative 6. So it's really negative 22 plus 6, which is negative 16, and you make it positive. Distance is always positive. Length is always positive. Only positive answers allowed. All right, so we're going to move on. Let's try this one. This is our real world problem. Okay, so we have a road sign. Can you see that road sign? What do the numbers on a road sign represent? What do those numbers mean when you're driving on the road and you see those numbers? It's miles, yeah, but it's how many miles away those things are from your current location. So when you see that line, when you see that sign, Paloma Road is 5 miles away. The rest area is 26 miles away from where you are right there, and San Diego is 286 miles away from where you are right there. Okay? Now, once you get to Paloma Road, how much farther is San Diego than the rest area? Once you get to Paloma Road, how much farther is San Diego than the rest area? Good. So how much further? That is a subtraction problem. How much further? Now, if you really think about this, does it matter? Did this part of the sentence matter at all? Okay, so once you get to Paloma Road, you're there now. So this is now 0 miles away. Now that you're there, how many miles away is the rest area? 21. Now how many miles away is San Diego? 281. How much further away is San Diego than the rest area? How much further? Very good. It's 260. It's 281 minus 21. Is that any different from 286 minus 26? No, it's no different. It would have been the same either way. This was a subtraction problem. We made this a little bit more complicated than we need to, but it's a subtraction problem. All right, take a look at your handout if you have it. If not, it's not a big deal at all. Okay, guys, so the whole premise of this problem is to show you that we're trying to find the distance from Lee's house to the mall. And we know we can count the distance from Lee to Rita's house. We know we can count the distance from Rita's house to the mall, but we can't count the distance from Lee's house to the mall. So we're going to have to, gonna is not really a word, I'm sorry. We're going to have to use a different strategy. What strategy do you think we could use? How could we find the distance of that dotted line? Good, good. So people are saying Pythagorean Theorem. People are saying a squared plus b squared equals c squared. What kind of triangle do Rita's, Lee's, and the mall form? What kind of triangle? A right triangle. A right triangle. Absolutely. You thought this was geometry? Pythagorean Theorem is a huge part of geometry. Huge. Like, super, super huge. So you can write this in your notes, or you could write it on the back where it says Pythagorean Theorem. It's up to you where you want to put it. If it were me, I'd probably just put it in my notes. So Pythagorean theorem is, of course, a squared plus b squared equals c squared. Now, we need to dive into this a little bit more. Do y'all remember the vocab words for a and b and c? One of them starts with an H. Maybe you were, yeah, hypotenuse, good. And then we've got leg, and we've got leg. Very good. Now, C always represents the hypotenuse. What do we know about side C? Tell me something about side C. It's called the hypotenuse. What else? It's always the longest side, yep. And if I don't have a ruler and I don't know which side is the longest, how could I find C if I don't have a ruler? Awesome. It is always opposite the right angle. Now, remember, Pythagorean theorem is only allowed on right triangles. You would never use it on a triangle that's not a right triangle. It's for right triangles only. And so you locate that right angle, and you draw an arrow away from it, and then you're pointing to the hypotenuse. So if you ever can't locate the hypotenuse, like sometimes it's weird when we like rotate these on you and flip them, it's always across from the right angle. So if I were to label these sides, hypotenuse, always across from the right angle. Hypotenuse, always across from the right angle. And then the other ones would, of course, be leg, 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 and leg. Okay? So the hypotenuse is the one we care about. All right, you can do this on the back of this page, or you can just do this in your notes. Please solve for x using Pythagorean theorem. So a squared plus b squared equals c squared. A squared plus b squared equals c squared. By the way, a and b are interchangeable. It doesn't matter which one is A and which one is B, if you were worried about that. Now, today it is very important that you have a calculator. Sorry, mine's really old. It's like ancient. It's from high school. While we're doing distance formula and Pythagorean theorem, you'll need a calculator every day. All right, so let's finish these off. 7.6, yeah. So what about for this one over here? Now, notice our x is in a different spot now. So you can move the 5 over now, or you can move the 5 over later. It doesn't matter when you move it, but either way, sorry, not the 5, the 5 squared. Either way, you're going to end up subtracting, whether you do it now or you do it after you square them. So either way, you should get x squared equals 336. And then the opposite of squaring something is square rooting. So the square root of 336 is 18.3. So the only difference between the first example and the second example is on this one, you were looking for a hypotenuse, and on this one, you were looking for a leg. So when you're looking for a hypotenuse, you're just going to add and take the square root. And when you're looking for a leg, you're going to subtract and take the square root. All right. So that's your review of Pythagorean theorem. Go back to the front of your page. Today is a little choppy. I'll just give you that. It's a little choppy. You round to whatever a worksheet tells you to round to. So the notes didn't tell you to round to whatever you want. All right, go to the front of this page and really just complete the first 3 rows of the table, because you're going to get what's going on after you've done it 3 times. Trust me. Go. All right, so I don't expect you to be done yet. I just want to make sure we're all doing this correctly. AB, the segment length, the length of AB is 5. Endpoint 1 is, it doesn't matter which endpoint you put first. One of them's 4, 7, and one of them's 4, 2. Change in x value, remember from algebra, that's like delta x. And the change in the x value is, 0. The change in the y values is 5. And so it's asking what you notice. AB is 5, and it's just the change in the y values. EF is another vertical one. So is IJ. I'm going to jump down and do CD. The length of CD is 7. One of the coordinates are 1, -2. The other one is 8, -2. Delta x is 7. And delta y is 0. So the moral of this story is that when a segment is either vertical or horizontal, one of the coordinates are going to cancel out, right? And that's why we're allowed to just easily count on the coordinate plane as long as we're vertical or horizontal, because the other coordinates just cancel out. You don't need to worry about 2 dimensions here. You only need to worry about 1 dimension. Yes, absolute value. You notice some absolute value. Just in case you would have done 2 minus 7 instead of 7 minus 2, you would want it to be positive. Yep. So we're noticing that it's pretty easy when our segment is vertical or horizontal. And we can easily find it, finding the change in x and the change in y. And one of them is always going to cancel out. So those are some observations we're coming to. So if we look at our picture again, what are the coordinates of R and L? Okay, so we need to write them down. What are the coordinates of R and L? So R is -8, 1. And L is -8, -6. Use the coordinates to compute RL. Okay, so that's easy. We learned that these are going to kind of cancel, and then I just subtract the other 2 and take the absolute value. So RL is 7. I know you could have counted it, but we're computing it. Very good. Okay, go ahead and do the other one. R and M. So we already know R, -8, 1. We already know M for mol, 9, 1. So RM is, well, the 1's cancel, and -8 and 9, absolute value, 17. Now, knowing what we know about Pythagorean Theorem, and then knowing what we know about what we just did now, this is 7, and this is 17, and we know we can now find this dotted line by doing Pythagorean Theorem. Oops. Right? We can do that by doing Pythagorean Theorem. And how did we find 7 and 17? It was delta x, and it was delta y. For one of them, it was delta x, this one right here. And for this one, it was delta y. So what we just did, and you might not have seen it coming, but I promise, what we just did was we derived the distance formula. We derived the distance formula by finding the change in x and the change in y. Change in x is just x minus x, and the change in y is just y minus y. And this right here, my friends, is the distance formula that we kind of derived by working on this. So, write it down over here, right here, the distance formula, the square root of x minus x squared plus y minus y squared. This is, not that one. But if I square rooted this, then this is also the distance formula right here. If you don't like the subscripts like x2 minus x1, you could just think of it as delta x squared plus delta y squared, and you take the square root. So really, the distance formula is just Pythagorean theorem in disguise. It's just a little more complicated than Pythagorean theorem, but that's honestly exactly what it is. Okay, so Pythagorean theorem and distance formula are the same thing. They're just in different forms. So the very last thing that we have to do today is take a look at the bottom of your notes down there. And notice that this graph is way different from the one on the front, where all of these were vertical or horizontal. These right here are all diagonal, so you can't count any of them. Now, what I want to point out is that in a problem like this, you could either use distance formula or you could use Pythagorean theorem. So, if I want to find the distance from A to B, I could make a right triangle out of it. I could do that, and I could count. This is 2, and this is 1, 2, 3, 4, 5. So to find AB, I could just do 2 squared plus 5 squared, and I could do Pythagorean theorem. But I could also do this. The coordinate is -4, 4, and the coordinate of B is 2, 2. So I want to show you what it would look like. I could also do this. I could do, it doesn't matter which one comes first, the x's or the y's. 4 minus 2 squared plus, and that would get me the same answer. So when you have a segment on the coordinate plane, you could either do Pythagorean theorem or distance formula. This. Determine the validity of this statement. The distance between 2 points is always positive. So determine the validity just means true or false. What do you think? The distance between 2 points is always positive. Yes, very good. So the validity is true. Determine the validity. That is a true statement because we're never going to have a negative length. We're never going to have a negative distance. So if you do get a negative answer, make sure you take the absolute value of it. Sometimes you won't be given points or segments on the coordinate plane. Sometimes you'll just be given 2 coordinates and you'll need to be able to do the distance formula. Now this doesn't happen very often. It doesn't happen very often, but it does sometimes. So let me teach you a quick trick to do the distance formula. What I do is I start with my template. I call it a template. That's my distance formula template. I write everything in there with no numbers. And I recommend you do this as you're getting used to it. The next thing I do is I circle my x's and underline my y's. I circle my x's and I underline my y's. Then, I just take the 2 circled ones and throw them into parentheses. Circled 1, circled 1. Then I take my 2 underlined ones in the same order and I throw it into parentheses. And then I've set up my distance formula correctly. So that's just my tip for, that way you're not getting confused by the minuses and the order and the subscripts. That's what I do. Now, you can simplify this, or you could just go straight to your calculator. So if you want to simplify this first, like, oh, I know 2 plus 3 is 5, and I know 8 minus 1 is 7, and then you can go to your calculator later, or you can just go to your calculator right here and put all of it into your calculator. The only work that you have to show is the setup. You don't have to show any work after you set it up. Okay? Is it 8.6? Is that the answer? Okay, we're going to do one more. I'm going to remind you how I do it. Template, minus, minus, plus, squared, squared. I circle, circle, underline, underline. Then you throw your circles together. 9 minus 5. We stick together, us x's, and then you throw your y's together. The y's stick together. You do not have to simplify it. You can go straight to your calculator, or you could simplify it if you really wanted to. Just make sure you don't mess up while you're simplifying it. So that would be 4, and this would be, what, 1? And then you could go from there. Sometimes it'll say it around to the nearest hundredth, and sometimes it'll say it around to the nearest thousandth, so it just depends. This one says the nearest hundredth, so my answer would be 4.12. Nearest hundredth is 2 decimal places, and nearest tenth is 1 decimal place. Okay. No, the 4 postulates will not be on the quiz tomorrow. Nope. Last thing, explain why it's not necessary to use the distance formula for vertical or horizontal segments. Because you can just count them. And the reason you can just count them is because one of the coordinates cancels out. So you don't need to do distance formula when one of the coordinates cancels out. Does the order matter when inputting coordinates into the distance formula? Explain. So what I would say is the order doesn't matter as long as you go in the same order both times. Notice on this one, I put 9 and then 5. So I did A first and then B. I could have done B first and then A. It doesn't matter, but when I'm putting the Y ones in, I need to go in the same order. So if I go A, B, then for the Y coordinates, I need to go A, B, and vice versa. So the order doesn't matter as long as you're consistent with your X's and your Y's. All right, that was a super long lesson. You have homework over this, and I expect you to bring questions over your homework so we can make sure that all of that we went through so quickly really did hit home and is committed to your long-term memory.